Greetings everyone! This month I'm coming to you live from my new home in Austin, Texas, my third and hopefully final location this year, at least until 2018. I'm excited for this month's November Math Fix, so without further ado, let's get started.
Today's Math Fix is brought to you by S.id.6.a, which asks students to fit functions to data and use those functions to solve problems in context. Let's take a look at our problem today. Students are asked to examine 5 scatterplots that represent the profit over time for 5 different companies. Given the data, they are then asked to make a recommendation to a potential investor on which company to invest in. Where might students start with this? Let's jump in. Students might initially struggle with the fact that all 5 scatterplots display data that appears to be best modeled by a linear function. If all of the relationships are similar, how do we make a recommendation? You might suggest that students start by sketching an approximate line of best fit, or regression line, for each plot. This will help them to start to think about how the plots may differ, and not just how they are similar. Students will probably initially notice the difference in the slopes or rate of change of each graph. It might make sense to ask them to think about what these slopes mean in the context of the scenario they are being asked to evaluate. For example, a graph with a lower slope would mean that the profit is growing at a slower rate, and a higher slope would mean that profit is increasing more quickly. Students might be tempted to say that the graph with the steepest slope is the one they would recommend for funding. However, there are other factors to consider. For example, there are only 10 data points represented here. How do we know this company is not experiencing rapid initial growth only to level off or even drop off after time? Other factors to consider, in addition to the slope, are the x and y intercepts and what they might mean in the context of this problem. For example, in this situation, having a positive y-intercept, like these 3 companies' graphs, means that the companies were profitable right from the start, assuming that this graph starts at the beginning of the company's history. What are some factors that might allow that to be the case? Perhaps the business owner invested their own money to cover startup costs, or they did not need to purchase any inventory to start the company. Alternatively, the company could be one in which the business provides a service that doesn't require any startup costs or fees. With the other 2 companies, having a negative y-intercept leads to having a positive x-intercept, which in this scenario means that it took them a bit longer to be profitable. This could be because they had to take out loans to cover startup fees or purchase inventory, equipment, or supplies to get their company off the ground. Additionally, they might have used money to advertise or promote the company, or to hire employees to get the company up and running. All of these factors will weigh into which company students recommend to win the competition. One final factor we might want to encourage students to consider is the strength of the correlation and the residual values. Although we do not have actual numerical values off of which to base this decision, we can tell which graphs appear to have a stronger correlation, and also if any might be better represented by a non-linear model by estimating residuals. Students may argue that it might be wise to invest in a company that does not have as much variation in profit, at least initially. Of course, the fun part about this problem is the dialogue that will occur as students argue and defend their recommendations. You may introduce this problem by showing a clip from the popular TV show Shark Tank. You could then assign individuals or groups of students to the different graphs and have students act out trying to convince a panel of sharks to invest in their company based on their scatterplot. They would have to create the context for their business, explain the factors that contribute to their graph looking the way it does, and convince a skeptic to take a chance on investing in their company. As a final push, you can ask students to create functions to model the company they are representing based on estimated values and make predictions for their company for a year from now. Any investor will want to know the answer to that question.
And that's this month's Math Fix, folks. As usual, we love hearing about what you're up to in your classroom, so don't hesitate to share with us your take on this month's problem. Remember, we'll be taking a break for the month of December, but we'll be back in the new year. Until then, we wish you and yours a happy and healthy holiday season.